We're always talking about keeping our data private and secure, right?
Hmm.
But what about like a new frontier? Have you heard about confidential computing?
Oh, yeah, definitely. Confidential computing. It's really like the next step in protecting our data. It goes way beyond what we used to do, the old ways.
Okay, so like what's wrong with the old ways? We've got encryption and stuff.
Yeah, we have encryption, but it's like we're good at protecting data when it's just sitting there or like when it's moving around, like in transit. But when it's actually being used, that's when it gets kind of dicey.
So like when it's actually being used. Can you give me an example?
Sure. Imagine you've got your car, you lock it up tight, but then you leave the engine running with the keys inside while you run into the store.
Oh, okay, I see what you mean. So that's the weak spot that confidential computing is trying to fix.
Exactly. That's exactly it. It's about protecting data while it's in use. It's like the missing piece of the puzzle when it comes to security.
That makes a lot of sense.
hmm
So how did this whole idea even come about?
Well, you know how we all kind of moved our stuff to the cloud, all our important information?
Yeah.
Well, people started getting worried. What if, like, the cloud providers themselves could just look at our data? Confidential computing basically came from that worry.
Okay, so you don't trust the cloud providers, but how do you make a secure environment like on someone else's computer? It seems impossible.
It does seem kind of like a paradox, doesn't it? But that's where the smarts of confidential computing comes in. So it's not just about software, it's also about using the actual hardware, like something called trusted execution environments, or TEEs for short.
T's, right. I've heard that term,
Hmm.
but I don't really know what it means. Can you break it down? Like, what are they?
Okay, so imagine like a super secure vault. But this vault is inside your computer's processor. It's like a separate little space where data and code can be used without anyone seeing what's happening inside, not even the cloud provider, nobody.
So like a tiny computer inside the main computer.
Yeah, exactly. Like a mini computer, but super safe and secure. And the best part is, it's become like a standard, like the Confidential Computing Consortium. They're a group of big tech companies working together to make this kind of data protection available everywhere.
It seems like they'd have to work together, right? There's so many different technologies and stuff out there.
Absolutely. You can't have one solution for everything. And that's why there are different types of teas. Think of it like different brands of safes, right? Each one with its own special features.
Oh, that's a good way to think about it. So what are some of the brands of these T's?
Well, you've got Intel SGX, AMD SEV, and ARM Trust Zone. They all basically do the same thing, creating these little secure enclaves inside the hardware, but they each do it a little differently.
Okay, so it's not a one-size-fits-all thing. I guess that makes sense given all the different computers and cloud setups out there.
Right. And then you've got another big piece of the puzzle, key management. It's like you need these really good systems to create, store, and even switch out encryption keys so no one messes with the data inside the T's.
Wait, so even with this vault, you still need a key to unlock it?
Of course, you could have the best vault in the world, but if someone gets the key, it's game over. Key management, it's like super important for keeping everything safe and sound.
This is getting complicated. It's not just building a secure box, it's everything around it too.
Yeah.
But hold on, let's say I set all this up. How do I know no one's messed with it, that it's legit?
That's a good question. That's where remote attestation comes into play.
Okay. Remote attestation. What does that even mean? It sounds technical.
It is a little technical, but think of it as like a digital stamp of approval. It lets users check that the T is real and hasn't been messed with.
So it's like a way to build trust, even when you can't see the hardware yourself.
Precisely. And when you put it all together, the hardware security, the key management, and things like remote attestation, that's what makes confidential computing so powerful for protecting all our data.
Okay, I think I'm starting to get it. We've got these TEs protected with keys, and we can check that they're safe. But what can you actually do with all of this? What's it good for?
That's the exciting part. There's so much you can do with this. Like, one of the coolest things is secure data collaboration. Imagine, like, companies working together, even if they're competitors, and they can share data without actually showing each other the data itself.
How is that even possible? It sounds like magic or something.
It kind of is. Let's say you've got two hospitals, they want to research a new treatment, right? But they can't just share patient data, it's private. Confidential computing lets them use all the data to train a machine learning model, But neither hospital actually sees the other one's data. It all stays protected in those TEs we talked about.
That's amazing. So it's like having a helper who can analyze everything but doesn't actually see anything.
Exactly. And this could change so much. Think about banks working together to catch fraud, or scientists researching DNA, or even like government agencies sharing intel.
So it's not just about keeping data safe. It's about building trust so people can work together. Are there other things you can do with it?
Oh, yeah, tons. Another one is supply chain management. You know how it's hard to track where things come from? Like, is it real or fake? Confidential computing can help with that. You can track stuff and make sure it's legit, but still keep all the sensitive info safe.
So no more knockoff products.
Yeah.
And people would know exactly where everything comes from.
Yeah, exactly. And that's not all. Imagine protecting ideas, intellectual property. Like if you're a programmer and you build an AI, you could share it with others without showing them the actual code so they can't steal your ideas.
It seems like this could change a lot of industries, maybe even give regular people more power, make things more fair.
It really could. But there are definitely some challenges too. It's not perfect yet. One big one is portability. Making sure things can work on different platforms. We have all those different Ts like Intel and AMD and ARM. We need to make sure things work across all of them so that's
Yeah.
not like a bunch of separate systems.
It's like if you go to a different country and their plugs are different, you need
Mhm.
an adapter to make your stuff work.
Yeah, exactly. We need a way to make everything work together smoothly no matter what hardware you're using. That's how it will really take off.
So connecting all these secure enclaves is a big challenge. What else is there?
Well, performance is something people are working on. Confidential computing adds a whole extra layer, so sometimes things can slow down a bit. But people are getting better at making the Ts faster and the encryption more efficient.
So it's like you want the best security, like Fort Knox, but you don't want things to be super slow.
Exactly. And then there's security research. People are always looking for vulnerabilities, ways to break into the Ts. Like, there are these things called side channel attacks where they try to figure out what's happening inside the T without actually breaking in.
So even with all the security, there are still ways people try to attack it.
Yeah, it's like a constant back and forth. Good guys versus bad guys.
Well, this is all pretty intense. But even with those challenges, it seems like confidential computing is too important to ignore.
Oh, absolutely. It's still early days, but it has so much potential to change how we handle data.
It really feels like we're at the start of something big, like a whole new era
Yeah.
of technology, and confidential computing is right at the center of it.
I agree. And it's not just about the tech, it's about how we think about data, building trust, giving people more control. It's exciting.
This has been a wild ride.
Yeah.
I feel like I've learned a lot about confidential computing, from the basics
Yeah.
to all the challenges and what it can do.
It's been a pleasure talking about it with you. It's so much potential here. I can't wait to see what happens next.
Okay, so we've talked about all the techie stuff and the hurdles and what confidential computing can do. But like, what does it mean for me? Just a regular person. How is this going to change things?
Yeah, that's the big question, isn't it? It might seem kind of abstract right now, but it really could change a lot. Like, imagine having total control over your data, even when you're using like websites or apps.
Total control. Like how?
With confidential computing, all your personal stuff like health records or bank info, even what you look at online, it could be used without anyone else seeing it, not even the companies who run the apps.
So like a personal security guard for my data.
Exactly. And it could make things fairer. Right now, big companies have all our data and they kind of use it to make money. But with this, we could control our own data and maybe even make money from it ourselves.
Wow, that would change things. Instead of being the product, we'd be in charge of our own information.
Right. And it could even change how the whole internet works. Like instead of everything being controlled by a few big companies, it could be more spread out, more decentralized.
A more democratic internet, where privacy is built in from the start.
Yeah, exactly. It's a future a lot of people are working towards. But we're still early in the game. It's all still being developed. But more companies are starting to use confidential computing, and I think we're going to see some really cool new things come out of it.
It's exciting to think about, what's possible. We've gone from protecting data when it's stored to protecting it when it's moving. And now we're talking about protecting it while it's actually being used.
Yeah.
It's a whole new way of looking at security.
I totally agree. It's a huge shift. But like any new technology, we have to be careful, make sure it's used responsibly and ethically.
For sure. Well, this has been amazing, really eye-opening. I feel like I understand confidential computing so much better now.
It's been great talking to you about it. It's a really exciting field with a lot of possibilities, and I'm really interested to see where it goes from here.
Me too. And to everyone listening, if you're interested in learning more, there's so much information out there. This technology is changing how we think about data privacy and security, and it's happening right now. Thanks for joining us on the deep dive.